Hi everyone, my name is Deanna Schreiber-Gregory, and my presentation today is Back to Basics, Running an Analysis from Data to Refinement in SAS. I want to start by talking a little bit about data science. This is a hot word that we've all heard. It's all over the place. It's gaining traction. We almost can't go a day without hearing it. Especially today in the era of COVID, data science has been something that we're talking about constantly. The big question is, what really is it? Well, data science is kind of all around us and encompasses the analytic process, which is the topic of this presentation. So data science itself is so much more than just the analytic process, but the analytic process is kind of the heart of what it is. In very simple terms, the analytics process kind of starts with data collection, goes into cleaning, then exploration, model building, and model deployment. Historically, what we've been doing is collection and cleaning is usually done by individuals otherwise known as data engineers. So these individuals go out, they collect the data, they scrub it, they get it all ready for analysis, and they're really kind of our data experts. So they know that data, they've really been working with it. After they're done, they send that off to data analysts and statisticians. A data analyst or a statistician will then take that data, explore the relationships, start building the models, deploy their models, check the models, do all of that fancy mathematical work that goes into what an analysis actually is. When data scientists came on the screen onto the stage to do their thing, what they basically are is the encompassing of both data engineers, analysts, and just topic specialists. So they're supposed to know the field that the analysis is being run in, and also the mathematical, computer science, just structure of data and analyses. So they're kind of supposed to be able to do it all and implement the actual field that this analysis is being done for into the data and the analysis process. So it kind of takes, or they help as like a translation into the interdisciplinary model that an analysis actually put into. The reason I chose COVID as the topic or the subject for this analytic presentation is because of the timeliness of it. We're still in it, and just because of the complexity and insanity that was COVID. To begin, COVID was a very limited time frame, so it started and kind of picked up speed very quickly. The data that analysts had to work with was all real time. So data they could have pulled even now, right this second, is going to be old data tomorrow, the next day. So it's something that they constantly had to trip over themselves to try to approach and to handle. Another issue with COVID is the inconsistent reporting sources and standards that were going into the collection process. So any two sources weren't doing their reporting exactly the same. There was no data standards. They weren't being structured the same. We weren't collecting the same information or in the same ways or with the same understanding of what that information was supposed to tell us. We also had little to no prior knowledge of what COVID was, how it was impacting us, and what it really could do. So we didn't really know what to test for. It was kind of all over the place. And then lastly, again, you see this inconsistent reporting sources and standards, but now at the other end of the process, when we're actually trying to push results out into the world. So that was also fragile and inconsistent because we really didn't know what exactly we needed to be telling the world. We just need to know we needed to say something. So when looking for COVID data to use in this presentation, I came across a lot of sources. So we have the CDC COVID tracker, healthdata.gov, WHO, Kaggle, lots of different sources, lots of different data, lots of different formats, lots of different reasons as to why the data was collected, lots of people analyzing it. That's really just what I wanted to say about this type of data. So the main thing I want you to pull from this presentation is not that it's about COVID, but that it's about the analytic process and how essential that process is in cases such as the COVID pandemic. We really needed to approach it carefully and with precise understanding and careful implementation, whereas we really weren't able to do that with the demand of knowledge now. So just that's really what I wanted to touch on with this is just understand or take away that the COVID data that we have is fragile, it's inconsistent, it's all over the place, But the analytic process, the things that needed to go into it, that never changed. And please pay attention to that part. All right, so what we're going to cover in this presentation today is how to choose and import data, some important standards, keys, and best practices, data exploration, data-driven modeling, matching your question to a model, evaluating your model, and then the conclusion. All right, so we're going to begin with choosing and importing data. For each of these different topics, I do want to cover both some key information, how to run that in SAS, and then best practices. So just throw that out there. All right, so choosing data. When choosing data, there are several different things that you need to take into consideration. Are you looking at doing a primary analysis or a secondary analysis? Primary analyses involve you actually going out and doing maybe a survey collection or collecting data in some way. You are the person that's actually collecting and putting this data together. A secondary analysis is usually when you go out and you find data that someone else has done, or maybe you have done before, but you want to do a different analysis on it. So it's data that's been collected without the key purpose of the analysis you want to do on it. Both of those different types of data itself are going to have different formats and caveats within it that you need to consider. There's also experimental versus observational research. So experimental is when you can actually randomize individuals into groups and maybe give them a different drug or give them a different way of learning that you're able to actually test the difference between those two groups. In observational research, you don't have the luxury of being able to randomize individuals and place them into the groups you want to see them in. You actually have to observe individuals or the subjects of your research in their natural environment or in a structured environment, but in their natural way. So it's ones that it's a type of research you can't manipulate, but in and of itself has strengths because you're actually able to see them without the pressure of that experimental aspect. Another thing you want to consider is, does the data ask or answer the right questions? So the questions that you may have might not be the questions that data is ready to answer. So just making sure that the questions you have match the type of data that you're looking to collect. Another thing to consider is also data structure. So survey, clinical, observational, or MIND data, all these different data types have their own limitations and quirks in them that you need to take into consideration, both from a theories perspective as well as a practicality perspective. Another thing to consider is sample size and generalizability. The sample that you're pulling, is it big enough to answer the question you need it to answer? Also, how are you pulling the data? So if I'm looking at COVID data across the United States, and I only take data from Illinois and New York, that might not be as generalizable to the rest of the United States. I can't say that individuals from Illinois and New York are appropriately representative of individuals in Florida and Alaska or Hawaii. I have no reason to believe that generalizability is there. So just making sure that the questions you want to answer, your data is prepared to do that. When importing data, it's essential to understand that data can come in a variety of different formats. It can come on Excel, SPSS, in text, or even in PDF, printed. So something you might have to hand key in or scan in and have an AI run that data for you. All of those different data formats come with their own limitations, their own understandings, and their own chance of error. So that's something to consider when importing your data and checking to see if it's appropriately been imported. Another thing to consider is that your data may need to be merged, so making sure that you have a reliable variable that you can merge your data on. If it's not reliable, you might want to make one that's reliable, or consider not merging. So getting into SAS. Getting data into SAS is actually pretty easy. Once you have it in a specific format, especially if it's like Excel or CSV.XL or in text format or SPSS or R, you're able to import that in. The procedure I use most often is proc import because I can pull it in and tell it exactly what that original file is so that it can import it in appropriately. Another thing to consider is data storage. So once you have that data pulled in, how do you want to store it? Do you want to store it as a permanent SAS file that SAS just has access to and is able to pull up with just one little line of code? Or is it a temporary file that once you shut down SAS, SAS loses access to it? That's something to consider in making sure that you have that implemented into your upcoming code for you to need to run it again. I always store mine in temporary format because I like to make sure that the original data set is preserved in its original form, but that I also can pull in a different one to represent the data set I'm doing the analyses on if I need to. Another thing to consider with data storage is that you can also export your data into another format if you need to, especially share it with other team members that maybe aren't able to use the program you're using, such as SAS. All right, so this is just my COVID example. So that first little group there outlined in in orange, is just what this data set looks like from the CDC as Excel. So then the next line you see is proc imports. That's me importing that Excel data set into SAS. And then you see my proc print line there, which results in that third little thing, or that little image table that's outlined in dark blue. That's the SAS view of that data set. So you can see that there's not much of a difference between how SAS views that data set once it's been imported in from Excel. So that's just the main thing I wanted to show you on this page. And then that last line of code right there is just me exporting it again. Maybe I did some adjustments. I want to export it and share it with my colleagues. I can do that without having to worry about there being any major changes that occurred. Plus, all of my changes have been documented. Okay, some best practices in this step is when choosing your data, pay attention to your sources. Make sure that your data is coming from a source that you trust and that is reliable. Understand that data has limitations. No matter if you're bringing your data in from a reliable source or not, that data itself has limitations as to what it represents. It has age. It has it might not be able to represent everything that you have that you want to have a question or an answer for. When importing data, you want to make sure that there is no excess information in the data sheet, so maybe summaries at the bottom of the data sheet that isn't actually an observation. Variables that have names, you should have variables that have names that make sense, so don't put something like later you'll see I have like Q12A. Well, essentially doesn't really mean anything other than it's the 12th question in a data set. So just make sure that you're using a name that you can easily interpret when you're running your analyses. If you have long names or names that you can't really put into a variable name that makes sense, use labels. That will make sure that when you're especially running your analyses, you can actually see what the variable is representing. Maintain an untouched original data set without adjustments. That will be worthwhile for a lot of reasons. A main one is that if you do something in your code that messes with your temporary data set, you're able to pull in that original one again and rerun the adjustments maybe up to that step. So you can retrace your steps. Whereas if you were to consistently overwrite your original data set, there's really no going back. So always keep an original untouched data set. Document your adjustments. You want to know when and why you did a certain adjustment to your data, especially if it's related to an analysis and especially if it's one you're going to run again. And then always review your log. Your log will tell you a lot about how that step was run and any issues that SAS saw when running that certain step. All right, so now that we got our data in, we're going to explore it. So the main thing I want you to take away from this section is just getting to know your data in the best way that you can and making sure that you can start to see some of the relationships that your data may have with each other. There are two main types of data that you could probably identify right now. There is numeric data and categorical data. Numeric can come in different types. It can come in continuous or discrete and interval versus ratio. Categorical can also come in its own different types. You have binary or dichotomous versus multi-level, and nominal versus ordinal, and then you also have dummy. On the tables on the right-hand side, you can see kind of laid out what the differences in these two variables, or these two variable types, or 8 variable types look like. So for numeric, you have discrete and continuous, interval and ratio. With interval, you do not have a true zero. So that's something to consider when maybe running like a means. So you can't really run a means on temperature the same way you could run a means on height, because 0 means something different for those two different types of variables. As also given discrete and continuous, continuous also like a mean of maybe 10.6 actually means something in continuous, whereas a mean of 10.6 doesn't mean anything in years. So there's no 10.6 BC. It's just 10. So that's something to consider in interpretation as well as implementation. For categorical, we have our ordinal, nominal, and then binary versus multi-level. Those really come into those really matter when you're trying to put differing types into a model, especially multi-level versus dichotomous, because those two things can, or those two types can really interact with each other in a nasty way. And also ordinal versus nominal can also determine how you interpret a model, especially if you're doing something like a logistic regression model with a binary outcome variable. How you answer a question with an ordinal versus a nominal outcome variable is different. With nominal, you don't have an order. With ordinal, you do. So it's just different things to consider. Another key thing about this step, which is actually the most important, is that this step is also your data cleaning step. So this is cleaning up any errors or issues that you're finding in your data as you're exploring. All right, so some procedures that you can use in this step are procedures such as proc-freq, means, univariate, and core. Freq is used a lot for categorical variables. You can see how many times a certain value of a variable occurs. Means, you can see means, standard deviations, minimums, and maximums. Same with proc-univariate. You can see much the same things, but with a little bit more information, such as skewness and kurtosis of your data. Proc-core, you can see correlations between your different data points. The data step I want to talk about here simply because I use that the most for any logging of adjustments that I need to do to my data. Some other helpful procedures could be proc contents to see what variables are in your data set and how they look, what format and labels they have. Proc sort, SQL, print, and then several different SAS macros. I love all of these for the data exploration step. All right, so here's my COVID example. You can see in the lower left-hand corner, I ran proc-freq, which is on the right-hand side, proc-sort to do my proc-means and univariate procedures, and proc-means is on the upper left-hand side, proc-univariate in the very center. So you can just kind of see how those results look like and how I'm getting to know my data. So with the proc-freq table, I get to see how often a certain hospital subtype occurred within a state. In the proc means data in the upper left, I'm able to see the means, each of those three variables that I wanted to look at by state. And then in the middle is my proc univariate, and I can see by state if there's any skewness or kurtosis or other main procedures I wanted to run on my data to get to know it. All right, so some best practices for this stage. Avoid categorical data as numbers if you can. If you store them as numbers, they can very easily accidentally get put into a model as a continuous variable, which will mess with results. So if you can, try to avoid it. There are times where having them as a number is a good thing, but for the most part, I would try to avoid that. Also, address missing data appropriately. We give missing data a bad rap, but missing data in and of itself is data. There's a reason it's missing, and that reason should be explored. So don't treat missing data as an obstacle that's just an annoyance, but treat it as an obstacle that in and of itself has value. It's a chance for us to find out more about our data by finding out why it's missing. Also, thoroughly clean your data. Make sure that your data is in a state that's just perfect for analysis. Don't expect anything less. Also know that data is more than just numbers and text. You are actually working with observations that mean something. It's people, animals, plants, environment. It's an artificial intelligence. It's weather. It's so much. Just know that there is something that's actually behind the data that should be treated with the value that it has. Also know that data is just a snapshot of information. It's not the whole picture. Think of data in its 3D form, that you're only looking at one side of it. You need to make sure that you're trying to see all sides of it. Don't just run one procedure and think you got it. Run multiple ones to figure out exactly what your data is looking like. Consider what the data is not telling you. Consider that the data has age. Data that we have now might not be applicable in the future, and data 10 years ago might not be applicable for now. Just know that and keep that in mind as a limitation. I also like to recommend swotting the data, which is basically identifying a data's strengths, weaknesses, opportunities, and threats. So just trying to find out like what your data really is trying to do and where it exists, within the sphere or the scope of the question you're trying to answer. And again, always review your log. Okay, so data-driven modeling. The big thing I want to cover in this is just to identify the roles of your different variables. You have predictors, outcomes, confounders, and covariates. And the identification of these is essential in inputting them into your research question. So you'll see a lot of the same procedures. It's very similar to the data exploration stage, but in this stage, you're going to want to look at actually the relationships of your variables. So for this example, I just ran the correlation procedure to try to see how correlated my different variables were so that I can make sure that those relationships are either identified or mitigated when getting into my model. Some best practices for this step is looking at what's been done. So in past research, has other research in your field identified relationships between variables that you need to take into consideration? So maybe you're working with surgery data and historically for this specific surgery type, males and females differed. That might be something that you want to explore not only in this stage, but that can be incorporated into your data modeling. I kind of like to consider this stage variable couples counseling. So just making sure that you're identifying the relationships and treating them the way they need to be treated. So do we need to break up the variables? Do we need to keep them together? Do we need to mitigate any arguments? Stuff like that. There's also data structure and compatibility, which is very math theory based. So identifying between your different data types, what challenges could exist and making sure that those challenges are met and overcome before you go into the model phase. And again, always review your log. All right, so once we've identified how our model is going to be set up, we can try to find a matching model type that we can put it into. So the big thing in this stage is just identifying and running model assumption checks. So some common model assumptions are listed here. Normality, randomization, and large sample size are ones that I really kind of want to point out because they're so common, especially in parametric models. Homogeneity of variance and absence of multilinearity in linear relationships are also very, very common. When you identify that an assumption for a model type might be violated, there are some ways that you can mitigate that. A lot of times you can do that through variable adjustment. So just some minor tweaks to how the variables are structured going into a model can actually get rid of that or lessen the impact of some of those different violations. But fatal violations will require a model change. So a violation of, say, randomization, there's not much you can do. You can't just adjust your data to fit that. So you might want to go with a different type of a model. It's almost never a definite stop, no go. A lot of times it's just, you just need to consider something maybe not that you're used to. All right, so some SAS procedures that are used a lot in this type of, in this stage is like for normality, we can use proc univariate, proc capability, homoscedasticity, there's GLM, reg model. The big thing I want you to take away from this is that there is a way to test all of the different assumptions that a model could have, and there's multiple different ways to test it. So no matter what your data contains and what your question is, you should be able to test the assumptions and mitigate them when necessary. All right, so for this example, I wanted to focus on multilinearity because that's a pretty easy one to identify and to correct. So for this one, I ran proc reg. I have my question 8, which is, are you currently conducting your job mostly from home now? And then I put some variables that I wanted to see had an impact on that. And then I ran VIF, Tull, and Cullen and was able to see if the variables that were in there showed multilinearity. That's what the next two tables are. If you want to learn more about this, I wrote an entire paper on it. But basically what this is telling me is that, no, it looks like there's not a lot of multilinearity within these models. So I could probably go on to check my next assumption without worrying about having to correct for this one because it passed. All right, so best practices in checking your model assumptions and picking your model. There are more than one way. So there are more than one way to check a model assumption. There is more than one way to answer a question. In fact, a lot of times if you run more than one method, it's probably a good thing. Like we talked about before, look at the model from more than one point of view. That's a good idea. Do not hesitate to switch models if needed. If you have a lot of violations, don't hesitate to try to look for a different model that might not have those same assumptions. That'll probably be a good idea. Too much adjustment is just adjusting, your data maybe too much. So just keep in mind that switching models is not a bad thing. It's probably a good one. Do not force a model. So do not force your data into a model. Do not force it to behave. Data is the way it is and models are the way they are. Don't force them to get along. I also like to call this the high rollers club. The more complex the model, the more risk you have in getting it wrong. So just make sure that your assumptions are not being violated and that your data is appropriate for that specific model. Note that null results are not necessarily a model failure, and always review your log. So once we've ran our model, we picked it, we've got everything in there, now we're going to evaluate it. So after the model is run, you're not done. Check for key model health indicators, such as predictive power and model fit. If you're working with newer data, maybe from a survey, another thing to do that you could do is consider the health of your data of your data indicators. So maybe validity, reliability, and generalizability of your data to make sure that it's something that maybe you don't need to go back and adjust for some reason, or that it's actually appropriate for the actual question that you're wanting to ask and get answered. All right, so there's different SAS procedures you can look at for power and model fit. For power, Cox-Snell is very common. For model fit, the bottom one there, AIC, BIC, Schwartz, those are some common criterion, but there are also ways for you to run other model fit and power procedures to check those. There's always an option. All right, so here's my code here. What I did here was in the first model, I ran it with an extra variable called total reported inventory. In the second model, I just removed that variable. What I want to look for is whether or not including that variable actually impacts my model in a positive way. If you look at the two tables at the bottom, you can see that it actually does. So the max rescaled R square is my power, and then the AIC, SC, and negative 2 log L at the top are my model fit. My power seems to have decreased. That model fit score seemed to have increased. That means that my model fit was worsened, and so was my power. So keeping that model or that variable in is actually something I want to do. It increased my power and my model fit. All right, so best practices for evaluating your model. Know that there's more than one way. So there are numerous different routes to test power and model fit. I recommend checking more than one if you can. Do not hesitate to switch models if needed. If you find that your model fit and your power are very poor and a different model would be more appropriate, even now, don't hesitate to switch. Also, do not hesitate to restructure your model if it's in poor health. So like I said, I looked to see if that one variable was actually meaningful because I had considered taking it out. Well, that test right there said I should probably keep it in, but if it was worsening my model, I would take it out. Again, do not force a model. Don't force a model to behave just because you think it should behave a certain way. Again, null results are not necessarily model failure, and always review your log. All right, so in conclusion, we checked out choosing and importing data, data exploration, data-driven modeling, matching your question to a model, and evaluating your model. So here are some key takeaways from each of those different points, but basically, treat your data as a living, breathing thing and make sure that your modeling and your exploration represent that. We are complex beings. Animals are complex beings. Everything around us is complex. It's not nearly as simple as it looks, and that's no different than their data. So make sure that you're approaching their data as the complex entities they are. Best practices, just like what is in the previous slides, but basically what I want to say is check your logs and don't force your data to do something that it's not meant to do. All right, so in closure, data is everywhere, and understanding data science is necessary in today's world. The journey should not be done solo. I highly recommend becoming a part of an interdisciplinary team that can explore all aspects of the data that you want to explore. We're all in our different fields of study for a reason, and we should be working together to answer our questions that we have for our world. All of us having an understanding of the analytic process is also essential, though, which is why I wanted to put this presentation together. No matter at what part of the process you are really impacting or you're really performing, we should all know what is necessary to get our questions answered, and what we're all doing to make sure that we get the information we need to better tomorrow. So here's some ideas for some further reading. There are lots of books that explain data science and the analytic process. I highly recommend going out there and reading them or perusing them or learning more. Also, I recommend checking out lexjansen.com for SAS papers. The SAS community itself is very steeped in data science, and we love talking about it. So please review the papers out there because there are some really good ones. Thank you all for coming to my presentation, and please do not hesitate to reach out to me if you have any questions. Thanks.